Okay, 10-3, interpreting the shape of data. So we're going to be looking at the distribution of data and whether it's symmetric or skewed. So the first exercise, the table below lists the scores of 2 students on their algebra exams, projects, and assignments. So this is student 1's grades for term 1 and term 2, student 2's grades for term 1 and term 2. Create a dot plot of the students' scores. So we're going to plot all these points. A dot plot, you just make a dot at the value. I'm going to cross them out as we go so we don't lose track. So you should be able to do this on your own, but you can just do it along with me. Not if you get a repeat, you just stack them on top of each other. $94, $92, $87, another $94, $88, $96, $88 again, $91 again, $91 again, $93, and $89. And hopefully you can see, if I look at the shape of this, this is very symmetrical, okay? It's perfectly balanced. All the patterns 1, 1, 3, 1, 2, 4, 1, 1, 3, 1, 2, 4. Perfectly symmetrical. So now let's do the same thing with this person. So 89, 83, 86, 83, 87, 76, 86, 87, 88, 90, 87, 86, 72, 73, 84, 82, 85, 86, 88, and 89. And if I draw the shape of this one, you should see that this is skewed. It's not symmetrical, there's a tail. Okay, and if you want to think about this, this is a little mouse. There's the body, there's the tail. So it's skewed to the left, or sometimes you see that they write that as negative. Negatively skewed. So toward the left or the negative, the left hand, we always think of negative direction. Okay, so then it says find the mean and median, for example, student 1. So the mean is 91 and the median is 91. I calculated those ahead of time. You can see the median is right there. The mean, I added them all up and divided by 20. That's the mean. How do they compare? They are the same. Find the mean is 84.35 for student 2 and the median is 86. So how do they compare? The mean is less than the median. Okay. And then it says, based on your answers from B and C, make a statement about the mean and median for skewed data versus symmetric. So for symmetrical data, the mean equals the median. For skewed data, the mean is less than the median if it's left skewed, and the mean will be greater than the median if it's skewed to the right. Which would make sense, because if you're figuring out the average and it has a skew or has some values that are really low, it's going to pull the mean that way, making it less. And if they're very high, it would pull the mean that way, making it more. So would this be true for all graphs? Yes. Okay, the shape affects the mean and the median, because if it's symmetric, they're the same, but if it's skewed, the mean gets pulled away from the median. When choosing the appropriate statistics to represent a set of data, you must first determine the shape. Symmetrical data, the mean is an accurate representation of the data. The mean and the standard deviation must be used. So if you have symmetrical data, you're going to give the mean and standard deviation as your measures to tell about the data. If you have skewed data, the median becomes more accurate, so you should use the 5-number summary. Now, there's always exceptions, but this is in general. Okay, so when you look at a set of data, you determine if it's symmetric or skewed, and then when it asks you to tell the data, represent the data, you're going to use mean and standard deviation if it's symmetrical, and you're going to use 5-number summary if it's skewed. So example 1, Use a Desmos to construct a histogram of the data and use it to describe the shape or the distribution. So I already put all these data points in my Desmos, so you wouldn't have to. So you can see X1 is all these data points from here. So now we're going to use the Desmos. You're going to go again, you got the keyboard, you're going to go to functions, and you're going to go to distribution. And it asks us to make a histogram, so we're going to go to histogram. And then over here, oops, sorry, hold on, I messed that up. I was in the middle of my table, so let me clear that out. I forgot that I didn't go to box 2, so always make sure you go to the next box. Now in box 2, I'm going to go to functions, and then to histogram. And then I'm going to make a histogram, and it says we want to make it based on X1 data. And then I'm going to make my boxes 10 units wide. Okay. And then I'm going to hit, that's it, okay? And then I'm going to zoom out with my graph, and it's giving me this as my histogram. And I could change my width if we wanted to play around with it. Let's say if we made them 5 wide instead. You can see the data is better. You can see the distribution better. You could go to like bars of 2 wide. And what we basically want to see is what is the distribution. So I think the 5 one shows it pretty clear and there's no gaps. So if you look at this, the distribution is skewed to the right. Okay, it's skewed to the right. So it says click on the keyboard. It tells you all the directions. We're going to change this to a 5 because it seems to show it better. Okay, and it says create a table. Okay, so we made the histogram. So now we're going to say it's skewed right. Okay, describe the center and spread of the data using mean or standard deviation or the 5-number summary. Since it's skewed, we're going to use a 5-number summary. Okay, so since it's skewed, we use a 5-number summary. So going back up to our screen, we're going to do what we did on the lesson from Tuesday. 5-number summary. So first we need to go to functions. We need to go to stats. We need the minimum. And we're doing, again, X1. Sorry, hit the wrong button. X1, enter, that's our minimum. Then we need the Q1. So we're going to go back to functions, quartile, Q1, and we're doing X1. And then comma 1 because we want to make sure it's the first quartile. And then we're going to functions, median for X1. And then we're going to go to functions. We're going to go to quartile X1, comma 3 because we want the third quartile. And then finally, we're going to do the max. So that gives us our 5-number summary. So 18, 23, 26, 34, 43. So here we're going to write those down. So we have min is 18. Q1 is 23, the median is 26, Q3 is 34, and the max is 43. So if it's skewed, we're using 5-number summary, so you can use the calculator to find those like I just showed you, and then you list them here. Okay, so we drew our histogram. We found the right table so we could see if it's skewed or not. We said it's skewed to the right because there's that little mouse with the tail going to the right. And therefore, we're using the skewed right 5-number summary to represent our data. Okay, so now we have this little table that talks about what a box and whisker plot looks like if it's negative, symmetric, or positively skewed. So for this example, we're going to construct a box and whisker plot. And once again, I've put this data in Desmos. I put a different tab. Here are all the numbers that we were presented in the table. So they're all here. And we're going to click in our next box. And this time we're going to go to, again, the keyboard. We're going to go to functions. We're going to go to distribution, so D-I-S-T, and we're going to pick the box plot. And then we're going to put in the data set we want is X1 because that's where we put all our data. And then enter, and then we're going to scroll out, and you can see that there's your box plot. Okay, and if we look at this, this looks pretty symmetric, right? If you look at the length of this part of the box and this part of the box, this tail and this tail, it's pretty symmetric. So we're going to put here symmetric. Okay, and then it says describe the center and spread of the data using the mean and standard deviation or the 5-number summary. Since it's symmetric, we're going to use the mean and standard deviation. Back to our calculator, go to the next box. We're going to hit functions. We're going to go to stats and mean, and we're going to use x1. And we've got our mean, and then we're going to use stat functions. Stats, we're going to go to standard deviation and put in x1, and we got our standard deviation. So then here we're going to list the mean is 14.4, and the standard deviation is 7.1, which means this data is pretty spread out. And you can see you got 2s all the way up to the 20-somethings. It's pretty spread out. So the standard deviation is, the mean is 14 within 7 of that. So somewhere between 7 and 21, most of the numbers are, is what that's telling us. So again, you're going to have to put a lot of data in to do this. So again, if you're doing your own, to put the data in, you hit the plus and you do table. Okay, so if you're putting in yourself, and then you put it only in X1 if there's only one set of data, and then again, you're going to use your keyboard and go to functions to do the functions that you need with the table, and you can create any kind of graph you want. Is it symmetrical or skewed? If it's symmetrical, you're going to use the mean and standard deviation. If it's skewed, like on the previous problem, you're going to use a 5-number summary, so make sure you use the right data.